we come, you see it to the next floor because the other one was the site plan. This was the site. Then we have that ground floor. You see it. Then the next floor. Then it moves to this next floor up to the top here at this position. And I showed you how we go replacing that on each floor. How? It's by the use of the grids. That's why you don't. When you delete off these grids, these corners may not give you the right position above the next floor. So if you to select, you copy select. I hope you remember that. You copy select this because it's the one that you're taking up. This pipe here. You copy selection. Oh, sorry, I erased. You highlight, copy, selection, but here there were no grids. But you must have a drawing that has grids. So maybe you take from this corner here to the next one here. This next one here. You would see. Are you seeing that it has come exactly the way I had put the other one? So that's how you move. You move the pipe up to the top. But it is more better when you have every drawing having grids. So you might take maybe a center between this, an intersection between grid 1 and the grid A. So the intersection there, you take it because you're going to find it on each one. It gives you the exact positioning. So that's how you move from the outer meter up to the top of the tanks that we're going to supply. But before coming down, because remember supply has to come from up to down, I want to tell you that it would be more easier if I design inside, because by the water supply is easy. Water supply is easy. Though this first design we did, as I told you, it was the first draft. We had not yet known the needs of the customer, but it is not feasible. Like, this project would be expensive if you have a water heater in each of these rooms there, because they are like hostel setting. But if there is a water heater, this is how you would distribute. I think you remember how we draw this, we work with this. Do you know how? I told you last time on the lightning, it's the same property. It's a polyline. You know, you come here, you can first draw your first one like that. Let us review it. Then you come to it, highlight, come to properties, see global width is still 0, so you can increase its global width. Let me say to 20. Let me say 25. Are you seeing how it has increased? Yeah. So this one, let me see, this one is property. It's 20. Yeah, you usually use 20. So you see, then you can bring it here. Maybe you're going to start it any point where you want it to start from. Let me say I want to curve it all over here. You can move it. Move it to maybe here. Then in this extreme corner, you place it there. I think you know how to change now, how to change colors and layers, because it's already at water supply, which is okay. But you can change its color from properties. Come here, change it to red. Are you seeing red here? Yeah. So you can add vertex. So I told you since it has two sides. You see one of the vertex, when you add it, it creates such a corner like that. But you can also work with this one in a way that you move this, then you bring this back here, like that. I see. Or you can add from this point here. Here, you see, you first highlight it, you select it like that. You come to this corner here. You don't click on it, you just put the cursor there. That box comes around this one. So you add vertex, then you move in the direction you would want. Add vertex enables you to change directions, you see it? So that's how you work with this polyline. So we've seen that. So that's how I came up with this. Have you seen it? Yeah. So for water supply, these pipes are casted. They are all casted in what? They are casted in the wall. So for it, we don't have, and since the water is being driven by what? By gravity. The most concern is this pipe that is supplying from top of the tank. This one here. It's the one that you usually size. You getting me? Yes. So I want you to learn about, because yesterday I left you with an assignment of learning how to size these these drainage tanks, but they are usually standards. Like now this one. Let me recap on this standard before. Okay, you struggling with it. Not everything you have to study. There are standards. So the minimum usually it's 40 for these things. We together? At that point from the sinks. Now there are points where you're joining. You see now from this sink to this here. Now this leaving the sink, maybe at this point here. You see here? If you are to label at this point here, because now we are casted in slab. We are from walls, we are now in slabs. At this point, it can't be 40. Why? You've added another sink here, you see, and another flow drain. So we can increase this to 50. You see, are you seeing?
Yes.
Yes, because I told you the standards 40, 50, 75. Then we come to the drain. Then here you can see we used 75. Why? For the wastewater. Remember, wastewater is the one connected to the sinks. There are multiple sinks at this floor. If you go up to the next floors, remember there are already 4 floors for this project up to top. So you're expecting like about eight of the sinks being connected. Though the 75 will be enough, you don't expect all those things to be functioning at the same time. You getting me? So 75 will be fine. Unless when you see a lot of those sink fixtures connected, a lot of them. So you can go there. There are those calculations. You can even go on YouTube. You make your life easy. But I've just given you the starting points. Then for the toilets, this is the smallest, the standard. The smallest is what? 110. This one that drains from the toilet to this pipe. It's ever 110. Though this one that drops down, it is also 110, but it can increase based on how many toilets are connected. It can be even 160 based on the height of that building, how many floors. Yeah, so all that I need you to review. Then the same things apply here. So you see we supply from top to this point here. This is our pipe. Then we make sure we have a valve here, because at every point, like I would say like every junction, we have a valve. It's like our CB, the way you say CB for electrical. At that point, we have what? A valve. Then this valve connects to the pipe that is supplying. Now, usually this pipe is 25 This one is 32 because it might be supplying even other what? You can find it is supplying other fixtures above this. That is one of the reasons. Another reason could be when this flow is really so down, when it is down. Now when it is far down, also the pressure would what? Matter. So I would want you to really, I don't want to go into those calculations. They are very simple. You can follow what? They are simple compared to those of electrical. Electrical had to be hid because you can cause fire outbreaks. Also, these ones you can cause issues if you don't follow. Why? Because they are casting these pipes into the what? They are really casting these pipes into the walls. What? So if you select long pipe sizes for these designs, that's where you find the guys complaining, man, we don't have pressure in water, what, because of your design, which wasn't good. So we connect to this. You see, we supply now the sink because these are casted in slab. We connect to sink. I mean, casted in wall. Remember, I told you in wall we can achieve the way I showed you in the drainage. We can, since it is a wall, we can really achieve different slopes. Yeah? You can slope as long as you are within it. So for it here, we don't even mind much. We just put the technician will work out with the slope. Then we bring this, a connection to the toilet. There is a valve here. Are we together?
Yes.
So those are you don't forget those skin points. Then we move, you see the water heater, we supply it. Why? Remember water heater, it gets cold water, then it supplies out for warm water. Let me kindly take up this call for just like 5 minutes.
Okay.
Okay.
Hello.
Hello?
Hello. Eh, is
Hello? Akram has just going to receive
Akram
a
still there?
call, but he said
Yes. Is
yeah, he
Akram
said
there again?
he had received a call. Yeah, he just wanted to pick up.
Okay, okay, fine.
Sorry for that. Sorry, it was an emergency call. So, where were we? How this is applied. So we bring also here. Martin, are you back?
I'm around.
Okay. I'm sorry for that, but it was inevitable. So we come here, then we also supply our shower here. So why do we put these two? Because we have two supplies, water, this warm water and this. So we come here to the warm water. You would see from the water tank, then we supply. Literally, water supply is easy here. At this point, water supply is more complicated up at the tanks. So you have my major issue was you first identify the points where these tanks, these pipes that are coming up, but you've not yet calculated it. You've not calculated it. Pardon. So you've not yet calculated this one here. So you just first place these, like you position them. Maybe this one is 25. It is usually 25 the time it reaches here, unless when it is supplying some other far unit, you might reach here when this pipe is also connected to some far unit. This way now there you can select like a 40, a 32. Yeah, this can continue as a 32 here. Maybe you're supplying something far away. But I told you there are also what? Calculations you can follow. The farthest, let me share here. Let me show you, I also have to guide you in a way how you do. Let me show you some YouTube video that will make you work easier. Well, these guys of MEP Academy. Seeing these ones, MEP Academy now, there is, under their videos, there is where they have water supply. Can put in water supply. Yeah, this one. This one. It is a short video, 12 minutes. But you get most of the what? The concepts of calculating those sizes. This one, water supply fixture. So they even give you that table, you can look at it. So yeah, it's these ones. Actually, they teach a lot of things in MEP. Even HVAC, this chilled water, central what they have all those things you can familiarize yourself with. You see data centers. You can go there for literature, not design but literature, to know what to do. Getting me to know components before even we start the HVAC design. You can go there, learn how it is done. It is a good. You see, for me, I even subscribe for them. These guys here. So those guys, it's good. You do. You do what? You learn from them. I've given you their what? Also, this one is a video concerning that. So you can go there and get that literature. 12 minutes. 12 minutes, you're done. So very, very easy. Are we together, Martin? Have you seen those guys?
Yeah, I've seen them.
Yes, so the resources I give you, they are ready. They make your research easy because I've used them, and you have given you a shortcut. You don't just go onto the online and you just get relevant data. So as I was telling you here, it helps you to position these. Why am I concerned of this? Because you're going to position here, you position this here, you know that, oh, I'm going to supply from this end, because down there the ducts, you position here from the ducts, here, there. So each floor, so you move from down, from the ground floor down, you copy all these pipes respectively. Let me say you've copied this, assuming I've copied that, every pipe, even this here. So you copy selection. You come to our intersection that I said here, for the grids. So you move that to the next floor, to this next floor here, like that. You move to the next floor here, selecting that intersection of the grids. Then you move up to the top of the roof. Why am I concerned of that? You see, after moving every pipe like that, you will know that here I'm distributing 3 pipes. Here I will have, because you're moving from each from each floor down. Remember, you'll find that this pipe here has moved up to this down floor here. However, there is even a separate one. You never know what you're designing. It could be the same pipe supplying up to down, but it could also be one pipe supplying only to this point, only to ending at this floor. You're getting me? So based on what you've designed down here, you'll find your way that you will have maybe 3 pipes at this point. You seeing? You see my point? Because at that point we are at here. You see here, at this position here. So why are we having the 3 pipes? Having that there, that continues to down. So there are 3 floors down that are having that. So you might find there are 3 pipes, but also those 3 pipes, they have somewhere where they are coming from. How are they being supplied? So after you positioning these to the top, then you already have your tanks, water tanks here. You know each tank. Now, based on what you've decided, is each tank going to supply each floor, or is each tank going to supply, a corner, or each tank, is it going to supply an apartment? Let me say if it is an apartment. You getting me? So you're planning for your distribution of this water. So for this case, let me see. Each tank was supplying. I see each tank was almost supplying each floor. To the way I'm seeing how they are moving. Do you know why? Because we are having 1, 2, 3, 4. 4 of them, of the pipes out from the tank, they come. You see, they make junctions, 4 of them at each point. So you would see that, why are we making 4 of them at each point? Because you think from each floor, you're having 1, 2, 3. Okay, you see, the 1, 2, 3. And at each point we are bringing the what? The 4 pipes. You think? Here we bought 3. Why? Because the upper floor, there is no supply here. Are you seeing anything being supplied at this point? No. So here we bring 3 because there are only 3 floors down. Then here, still there are 3. Why? At this upper floor here, we don't have anything that we are supplying here on this last floor, like the last floor up. Then but we brought our 4 pipes here, and you see one of them doesn't continue the other side, it only continues this side where we have the 4 points, because when you come here, we have a kitchen here. You see, we have a kitchen, meaning that this pipe here, this tank that is supplying, you see this one, that is supplying, it means that it is supplying only that flow on top, where if you to trace back what it is supplying, you would see that tank, you would see from that tank here, it is only supplying fixtures for the upper floor only, if you to trace. Then also the others are supplying water from to the other floors. So meaning each floor is being supplied by a tank. You understanding? So that's how we work around with this. So I shared with you this. I want you to really follow it, interpret it very well. So you see here we label 4 of the 32 that are going down. So each ends at a what? At a certain floor. You getting me? So that's how it is working. So that's how you do this water distribution at the roof level. Yeah. So literally that is the water supply, and you see this one that is coming up. It is, remember we brought 4 of them, they are coming. So each to each what? To each water tank. So here you just showing the technician that take this direction of the pipes like this. The 2 are going to end here, then we continue with the other 2 that are going to come, and one ends there, one continues here. And you can lay them on top of this what? This roof. You know, it's like a slab, and actually not a slab, like these walls that are enclosing the what? On their top, you can be laying those pipes there, because remember water has to get into the tanks from the top, and these ones you see here down, they are moving down. So that's how we do the water supply. So let us go to, you asked about, I'm going to use this residence about to show you what we do for this, the rest below. So this was someone who's home. It's a luxurious home, very luxurious and big. So I wanted to show you how the low, it's called low current system layout, where we have cameras, motion sensors, intrusion alarm, arming keyboard, intercoms. You know what an intercom is, Martin?
Something to do with communication. I'm not so sure what it is.
Okay, do you know these are homes whereby I usually see them in movies, but also here we design them and people do implement them. Do you know these are whereby you go to a home on a gate, you reach the gate, and you call, there is a monitor like thing, so someone is seeing you from inside and can talk to you when for you at the gate.
Like maybe someone asks you when you're at the gate, like, who is this? What do you want?
What do you want? When you're at the gate, and the gate is very far.
Yeah.
Those huge farmhouses. The gate is very far and is also far, whereby even the opening of the gate is remotely, it's done remotely. So after seeing who is at the gate, he opens for you. So that is called an intercom unit.
Okay.
Because it comprises of communication. It has a camera, it has an audio, it has it even has the control system of the what? So that is an intercom outdoor unit. There is one which is outdoor and one in indoor. Indoor, you won't find, also outdoor you can find a speaker there. a microphone, sorry. A speaker and a microphone, all those are embedded in one unit. Like, because they have to communicate. If it is a delivery guy, they will ask you, what have you come to deliver? Who ordered it? You have to reply. So it's a communication system of different things. So you can research more about it. So we have speakers, like wall mounted, ceiling mounted, audio system control points, panic buttons, then also what? Alarms. So how do we install them? So as I told you, we don't show their connections, you just show their positioning. So you would come maybe for this house, to the main entrance, you expect this intercom unit, an outdoor intercom unit maybe there, and an alarm system. It's an alarm what? Intrusion arming keyboard. Do you know this one? Have you ever seen this intrusion alarm keyboard? You usually see them in offices. There is some keyboard that is, you find that. Let me just copy it. You see it from Google. It is, I think now you can understand this if you've ever seen it in offices. Some of them, they're like, capability phone. Some kind of things like that, not rectangular in this way. So these units here.
It's like on the wall. Is it maybe put on the wall somewhere?
Yeah, put on the wall. Now the use of this, when you open that door, you have to put a code into it as you open that door, because if you don't put that code, it automatically triggers an alarm. You can read about how it works, but that's it to me. I've ever encountered it in some office, whereby when you come to the office, you open that door. When you enter, usually actually in offices they are indoor, they are not outdoor. Also here, I think it had to be indoor, maybe here. It had to be indoor, not here. So when you enter, after you entering, it senses the sensors, the motion sensors, this one, motion sensor here, will sense you. So after sensing you, it is you to put in that code before it gives you some time, like maybe a minute or 2 minutes, based on how it was programmed. So it gives you some time. If you don't put in that code, it will cause an alarm. It is also a defense unit, sort of. So you see our motion sensors, they are at points of what? Major entries. So here at the entry 4, where you find it there. Then this is our alarm control unit. This fire what? Yeah, this is sorry. Yeah, the intrusion is inside. I did the right design. This is just an alarm outside. This is an alarm. It is okay being outside because it alerts neighbors. So this is what I told you. When you enter, the motion sensor detects you. So you come to the intrusion unit here, put in the what? The code before you continuing. If you don't put in the code that you had set before, it is going to cause an alarm. It is going to trigger the alarm. Then we have our intercom indoor unit here. If someone outside there rings the bell at the gate, maybe you would come to, is at this intercom unit. Remember, it comprises of a speaker, a what. So instead of having our indoor bell, it's all embedded here. If someone is on the gate and has rung the bell, this will also have a sound output. That's why it is just there. It is almost in the center of the house, whereby it will send, send communication this side, this way, wherever you are, it will have to send some sound. So you would come here and see who is on the door. Pardon?
Is it better to put it maybe, let's say, in the living room or in the dining room, or somewhere where every
It is yeah, where someone can access. Here you see it is not in the living room, it is here in the saturation. It is a common area. And why did I put it here, not this side? Because you see, imagine you are at this point here in this guest room, yeah, this way, this far, and remember this is a story house. And we also up is there, so it is connected to the up. But let us consider this one on the ground floor only, assuming you are here. I mean you are this far, or maybe this veranda, this way out, and this unit is this way. Yes, they can make sound up to that point, but why do we have to patch? If you make this one this, if you make it over to be in this sitting area, meaning the one you're going to purchase will have to be of higher dB in terms of, I think you know what dB is, what a dB is in terms of sound, like higher decibel. It is called what? Bill now.
decibel.
Bill is an expert here. They understand these systems now. Bill, are you on the call? Okay, let
I'm
us
not so
continue.
sure. Yeah.
So this, it is really, it is better if you have such an option to put it at this position than being this way, because of considering the positioning, like having it this way far, you are at this point this way, then for it is this way. No, because all these walls obstruct that communication. But anyway, yeah, you've known what it is. Then we can have a camera here. Why a dome sitting? You know what a dome camera is? This dome camera, it can see in different angles. So we've put it at the entrance point because someone comes from here, is going to go there. And I put a lot of cameras in this house, but it depends on the client, because for you, you see which points are really critical to have a camera. So it will depend on the what? On the client and his technician, their pricing, on how they cut off some of the things. But for you, you follow your literature that you have to design, because you know motion sensors are put at points of entries. Like at that point, you put a motion sensor there at the corner, the top. Now this is our home. We expect speakers. So you have your speaker here, you have your speaker here, you have its control unit here. Wall-mounted speakers. Have your wall mounted there, wall mounted there. You have one here, you put here a dome camera. Why? Because someone can enter from here. You see? Also, maybe you put your camera here, because you put this in this position, someone can enter here, or from here you can be seeing him. Then you put this one here. This one is a bullet camera. For which it has a wider view. You can put it here, but it can view all over this area like this, up to this side. That's why I positioned it in that direction. It is usually for outside view. You put this one here, it is going to view all over here. We have put this one, it's going to view all over here. This one views this point here. Also this one views here. Anyway, this design was so exaggerated, but anyway. Motion sensors, as I told you, at entrance points. You see this can detect here. Once someone enters, opens the door and enter, it can detect him. Then here we put our ceiling mounted in the dining. You control it from here, this unit here. Also in the kitchen, you control it from maybe there. It's ceiling mounted here. Alarm. We have our alarm here also, it can trigger. So there. So then outdoor, maybe I put this in these common units, the kitchen. And you see cameras, I've put them at ordinary common units. Here you don't expect to put a camera in the guest bedroom. What do you want to see really? But you can put a motion sensor for purposes of protection. If someone maybe enters from here and he has not triggered, they are called what? Those ababi. When he enters from here and he has not, this is not triggered here, the motion sensor senses him automatically because he'll have to pass somewhere. It senses motion within the room. So, and this is not triggered, it will automatically do what? It will automatically cause the alarm to trigger. So you find it here. So if he breaks from this car window anywhere, that's the purpose of those motion sensors. They are really connected to this. So even these points where cameras are not there, we still have protection in that way. So we also come here to the next floor. Put a camera here because it's the staircase. Someone comes in here, you can see him. Anyone entering others' bedroom, you can see them. So a master bedroom, we don't want to congest it down, so we put this ceiling mounted what? Also in the prayer room. So you can really see the matter of what? Positioning. Martin, have you appreciated this?
Yes.
Yeah.
Actually, the fact that it's on its own drawing is just shows that the. I thought it would at first I thought it would be like combined with a small power and the small power drawing, but I've seen it may be overcrowded if you combine them.
Okay, it depends on what you're designing. There are some designs whereby, but you see this one is so much exaggerated here. It is a luxurious home as you see. So when you combine it with the lighting here, it is too much. But sometimes there are some designs I do whereby I just put maybe the smoke detectors within here. But here I do separate them. Then also, let me see, did I do, because I've not seen the smoke detectors here. Like that, didn't I do them? Remember doing them? I think I didn't do, but it has to be there. I forgot to put the sensors here, sorry, for this design. So some designs become too much. It's only one home, but it has all this. So you can understand. But anyway, a smoke detector. Smoke detector, let me talk about smoke detector and a heat detector. A heat detector is put usually in the kitchen. Okay, places where you expect fire, you expect smoke to be there. So like here, you expect what? Fire here. So you would put here a heat detector, not a smoke detector. So you can put one here. Then here in the living room, you can put a smoke detector, one smoke detector in each bedroom. The rest you can just go positioning smoke detector. But as you're positioning them, Actually, smoke detectors, since they are usually ceiling mounted, we can put them with lighting design usually, or with a small power here. Actually, they are usually put here, the small power design usually here, for smoke detectors and heat detectors. Those that are there for fire protection, you can place them in here. They're together. So literally that is the design. You position those. But now you see, for a well detailed, of course you have to do its own layout, because you can see if you put it with these others, you're overcrowding. Then maybe one other thing that you can lastly do for coordination, you can do this. You see, you highlight everything here. You see, you quick select. So this is the purpose of working within layers, because of quick selecting. So I would select not equal to 0. Why? I want to see the coordination, not equal to 0. So maybe I copy somewhere. I copy at some point of the grid, maybe here, maybe here. What am I trying to do? I'm trying to see what have I positioned. Is it right? If I place it here, is it not coordinating? Is it not crashing with, you see, not crashing with lighting and the rest of things, you see. Yeah, wall mounted. You didn't expect the speaker to, to crash with this switch you've put there. So that's the coordination I mean. Maybe if I put it there. Also, the camera positioning, not under the lighting. You seeing? Are you seeing? So here it is not with, it is not, because this spotlight is away. It's on a gypsum. This one is a wall mounted light. So literally that's it. And we are done with our design. So after there, you can Control Z. So that's how we finish our design. So the last thing that I was going to teach you is the printing. Is the what? The printing. The printing. So how do we print? Our electrical drawings are usually not to scale. Usually they are not to scale, because they are done in, they are worked on in conjunction with the architectures and the structures, everything. So, and the rest are on to scale. These ones are not to scale. Our design, us doing these spotlights like that, me working to with an original design, like whereby if this wall is of thickness 200, here in my design it is 200, then later I print it not to scale. It's because I would want to bring out, because these guys who are going to install these lights, he will read the plan and see that, okay, here there are how many lights. I'm seeing 1, 2, 3, 4, 5. An experienced technician, electrical technician, is well equipped with concepts of the uniform lighting. He knows that I have to space these equally. You getting me? And he has to offset some distance from the wall. Yeah. So after him knowing that, oh, they have put 4 of them, of what specification, these ones, for him he has to put into action. So he can really just look at this and know, because from our design for us, we've known that here we shall need 3 of them. And I've showed you all the calculations, how we come to those decisions. So if we are not to print to scale, and based on what you want to print to, but we usually print to A3, you can print to A3. So you can come here on this print command here. You continue to print a single sheet. You print to a PDF. Are you seeing? This style here of pen, usually select this. That one you can leave it as displayed. The DPs are 100. You select the page paper. Usually we print on ISO A3, or those that are at A1. I'm going to show you also A1, but usually A3 and A1. So we come to this, the one that makes that. Then fit to paper, yes. Portrait, yes. So you print a window. When you select print a window, you select the window from this edge of that to this edge. You following, Martin? Are you following? Then you press
Yes.
So when you press OK, you come here, select the direction. Maybe you created a folder, maybe there, and you created a folder PDF somewhere in your project file. In your project folder, you have your PDF. You could select PDF. You can call this E1 because you have to combine them later. E1, save. So that's how you print your first sheet. Oh, which paper size did I select? I think I selected portrait instead of land. So if I'm to print again, you come here, since I already printed the previous, you see? So landscape, you print to landscape. Then this shows you the outlay. It's not really fitting there. Let me see paper size. I want to center this. I'm forgetting what I usually do. Fit to paper, center. Center the plot is here. See, now it is well centered. Are you seeing it?
Yes.
Initially it wasn't centered. If I undo that, it wasn't centered. Now it is centered. So when I press OK, then again save it as that. Yes, I want to replace. So you see how it is well centered. So that is your drawing that you've printed. As your E1. Then after you printing all those pages one by one, do you have Adobe on your PC, Martin?
Yes.
Yes. So you know how to combine PDFs.
Yeah.
Then you go to Adobe, combine those PDFs, you form one PDF. You print these in you print them in order. This earthing usually is your one, then lighting ground floor, then small power ground floor, then low power current ground floor. So you first finish all the ground floor. From there, you finish all these of ground floor. That's how you even label them. You to see my labeling here of the drawing. Okay, this is E31 because we have some site drawings. So this lighting on the site lighting, lighting on the site, it's called site planning. It is my E1. Then you come to the camera, the low current systems site plan. So it low current system site plan. Then this comes to E3. Then we continue with this of ground floor, E4, E5, E6. Then we now come to second floor, E7, E8, E9. Then we come to this. This wiring comes next, E10, then the lighting last, lighting protection last. I think you've understood. That is one way of printing. Then let us see if I'm to print. Now this one is complicated. Printing to scale. The other one was for the case of not to scale. Now printing to scale is a bit complicated. How? You have to print using layers, this layout. So you've modeled here, you come to your layer. Though this is already a designed layer. If you should see the reference I shared you, it already has that layer. Let me show you how I create this layer. So let me come to layer 2 here. So layer 2. So let me just delete everything. I start from 0. So you have your layer here. So after selecting layer, you see this on top. It's a layout. You come to layout. Then here you are setting a page setting. So it is layer 2. You modify. So when you do modify, you come, you select the paper size. It is ISO A1. Here you select it. Maybe you want the landscape. This one. You select it. After selecting, you can select this to be that maybe. You plot 2. The plotter is W to PDF. It's a landscape, which is okay. This scale is an issue. The scale here, you make sure it is 1:1. This one, you see, 1:1. You center your. No, here in layout it is. You make sure the scale is 1:1. Then you press OK. So you've set the page. Then you close. So this is the page that you see. It's called, this is your A1 page. So when you double click outside here, you are editing what is on page. So there is, now you don't see what you're going to print. So you type in MVIEW, this one. This enables you to draw your viewing point, like this, on the page, what you want to view, what extent of the page do you want to view. Let me repeat it, MVIEW. So this is the extent of your page. You can leave some allowance a little. So you want to view your page. Martin, I think you being observant of these steps. Maybe the recording is being done. Okay, so that is MView. When you do MView, everything that you have here in the model comes to place. So when you double click inside here, you are editing what is here. And double click outside, you are auditing only the what? The page. Are you seeing it? So outside here, then you come, when I double click inside here again, I come, I select my scale, which is 1 to 100 maybe. So I come, I pan. You see I'm panning, not scaling, not zooming, I'm panning. So again, you set your 1 to 100. So you pan around this so that it fits very well on page. So you can double click outside, you come, because you want this M view here to fit, to be closer to your boundary that you set. You can move it like that, like that. I see. So that's it. Though you can see you're not centering within the what? The page. The side is far spaced. So how do you go about that? You can move this a bit away, like that. So that you come double click inside again, pan this to move towards your M view. You move to the other side, like that. Double click outside, you come, you can move this. Okay, still it is not centered, but you move around like that. So from there you can just print. Because you already set your layer, so you don't need to do anything. You just continue to OK. So you can name it also E2, maybe E2. So we see how our E2 comes out. So this one, it is to scale. Why? We scaled. If I show it to you, this is our A1 page. You see how it has come out. This one is to scale. Why? You have scaled. If we double click inside here, here, you see it is still at a scale of 1 to what? 1 to 100. So here in the model side, you had put this 1 to 100, but you scaled it from where? From layout, not from here. You scale it from what? From layout. Yes. So it is to scale of 1 to 100. And also other thing, you make sure this, okay, there are two ways you can do this. But for me, what I do, the easiest way, what I do, I make sure I do my kind of A1 page within the model. How? Remember A1, first of all, what are the dimensions of A1? It is 841 to 5. You can search here, or you can even go to, you can search here. So A1 size. So it is 841 in length and 594 in width. So, but remember, that is a paper. So in real time, if I'm to scale to 100, remember, if I'm to scale to what? 1 to 100, I'm going to multiply that length times 100, which gives me what? 84100. So you can see the length of this boundary that I've done. If I'm to do properties, are you seeing? It's not exceeding it, but I can enlarge it to exceed that, to reach the 800 maybe. At least maybe eight. I've multiplied times 100, so at least 80,000. Is it 80,000? Anyway, you can see it. So I make sure my boundary is scaled, my frame is scaled to fit those what? Dimensions. You getting me? Also this you can see if I'm to do properties. It's about 50. Remember the other one is 591. So this is 527. But since I multiplied by 100, it exceeds. You getting me? So by the time you're scaling here to that 100 that you are scaling here in the layout, already the boundary is up to almost that what? Page size. You getting me? When you apply your what? Your scale. We together?
Yes.
Yes. So that's how you print and how you scale. So if we are done with that, for sure we are done with the course, the introduction bit of it. So maybe what you would need is to get familiarized with those low current system equipments. You learn how to work with them. You can even study how they are connected. They are easy things to connecting cameras. You can go on YouTube, you see how someone installs. What does he follow? What are the those cable sizes? Cat 5E, what do they mean? What do they, you study about those, because you see, you can install for such a house, but when you go for a big project, you have to do a report, an installation report, whereby you're going to describe everything. For a huge project, even the cameras, you're going to describe their types, their everything. So you need to really make research based on what on your scope of the project. Are we together?
Yeah.
Okay. So with that, I've closed it. We are done. Anything that comes up, you can inbox me. We see a way out. Yes. Can be in touch.
Yes.
So have a nice weekend.
Yeah. Thank you. Thank you.
You're welcome.